Our topic today is unifying the DevSecOps journey, the MITRE SAF as a force multiplier. Hi, my name is Aaron Lippold, and I'm the inventor and chief architect of the MITRE Security Automation Framework, or SAF. Together with my co-captain, Brett Kreider, and software engineering team and lead instructor, Emily Rodriguez, we want to explain how the MITRE SAF can streamline security aspects of your DevSecOps journey. We'll also demonstrate the SAF model and how it serves as a force multiplier to increase the impact of our growing security community by delivering open source, reusable applications, how we bring those techniques together, how we build libraries to help make it happen, and how our tools help automate the security process.
Those of us who've navigated the security validation lifecycle know that it can be quite tedious. It starts with identifying the right implementation guidance, conducting automated and manual security tests, interpreting the results to weed out false positives, and trying to keep track of all the vulnerabilities that need to be remediated. On top of that, security is often bolted on at the end of the development, with developers fearing the results of a security control assessment because they don't really know what the security posture is. Today, we're going to show you how the SAF can fix many, if not all, of these issues. To address these challenges with the traditional validation lifecycle, the Security Automation Framework has three main goals. First, the SAF accelerates the process of delivering secure, production-ready software, which in the federal space we call the Authorization to Operate, or ATO, process. The SAF automates security configuration testing, aggregating all the security assessment results into a single dashboard that informs developers of security vulnerabilities early and throughout the lifecycle to expedite remediation. Developers can know that their software is ready for security assessment. Second, the SAF builds security into the development process. SAF content aligns with common standards such as DISA STIGs, CIS benchmarks, to validate secure, trusted configurations. SAF automates this process through implementing security requirements in existing DevSecOps processes, thereby shifting security left or early in the pipeline. Developers and assessors can both validate that the application meets the security requirements. Third, the SAF enables continuous assessment. SAF's automated toolset and visualization capabilities aggregate and visualize the results of all continuous monitoring tools into a near real-time security status dashboard. Operators can monitor security status to manage security risk over time, supporting ongoing or continuous authorization. Let me add two more things that may compel you to listen to the rest of this talk. Number one, all SAF content is free under the open source Apache 2 licensing and is currently being used by multiple vendors, federal agencies, and private sector companies. Number two, the SAF Heimdall data format is currently in the process of becoming an international standard through OASIS. This will instill even more confidence in the user community. Another great example of the impact of SAF is the NIST OSCL team and the Orion project. The Orion project brought together key federal agencies, vendors, and the academic community to develop a proof of concept demonstration on how to support rapid delivery of authorized, secure software using automation and standardization. Orion leveraged technologies ranging from NIST OSCL, GSA's GovReady, MITRE SAF, and other vendor-specific products. The full report is at the GitLab link on this slide. If you'd like to see a great publicly available example of SAF in use, you can look at the Center for Medicare and Medicaid site at saf.cms.gov. You'll see the same SAF capabilities developed by MITRE and the CMS security community, but they've been tailored specifically to CMS. They are available to all developers, assessors, and monitoring teams. CMS has had great results using the SAF. They've streamlined their ATO processes. They've automated security in the DevSecOps lifecycle. They've automated security control assessments, and they've enhanced their continuous monitoring program for both on-premises and cloud implementations. On this slide, we highlight specific SAF use cases across the lifecycle: planning, development, assessment, operations. When we speak to executives about planning, they're interested in implementing DevSecOps best practices, maturing their DevSecOps implementation. We can help them to identify processes that would benefit from automation and even specific SAF tools or techniques that can help them in this journey. When we work with developers, they're looking for automated scripts to support hardening and to validate their control status prior to assessment. SAF techniques can be used to set thresholds of security debt from sprint to sprint and to store the evidence of remediation to share across teams. Assessment teams have used SAF to aggregate the results of all available security tests, sometimes called risk information sources. Rather than rerun these tests during each assessment, they can reuse the results and prioritize checks that will help them focus on root cause and support risk assessment rather than simply control compliance. Continuous monitoring and operations teams can use SAF to aggregate the results of continuous assessment tools, visualizing the security posture aided by the latest results. Once a finding is identified, they can assign remediation across the appropriate team and then track mitigation, with all members of the teams visualizing the same results and speaking the same language.
So let's take a little bit of a deeper dive at the SAF's 5-pillar capabilities. The SAF provides a planning pillar to help develop security guidance or choose or tailor that guidance. It also provides security hardening, security validation, security data normalization, and security data visualization, all under one roof. The SAF tools can help you manage the entire security validation lifecycle. We partner with many different sponsors and companies, and our content is open source. With all this content and variation, everyone's security validation journey is different, so you can pick and choose which parts of the process are applicable to you and apply them as desired to your teams and environments. So let's take a look at this from left to right. Starting with the plan pillar, your organization must meet certain requirements such as SRGs or security requirements guides, STIGs, security technical implementation guides, CIS benchmarks or a Center for Internet Security, or a vendor checklist. The SAF includes a tool called Vulkan that can assist in creating your configuration benchmarks. We've seen that this automation alone can save hundreds of manual hours, and we will demonstrate this tool in a little bit. Once you have the requirements identified or developed from the plan pillar, you can leverage the SAF Ansible, Progress Chef, Puppet, and Terraform scripts to harden operating systems, databases, and really the entire DevSecOps stack. We call this compliance as code because the scripts enable you to configure the environment at each build. To simplify automation in the security lifecycle, we created a command line utility tool called the SAF CLI. This eases the different steps along the way. We also provide security validation as code via inspect profiles that developers can add to their CI/CD pipelines. These validation scripts are completely independent from the hardening scripts. Those inspect profiles only assess configuration though, so there is still a need to use other security tools to test the code and environment for common vulnerabilities and weaknesses. This makes it useful to be able to normalize data from other security data formats and show key information, all of them, such as the name of the control or requirement, its associated NIST 853 tags, whether you passed or failed, and how to fix it if you did fail. We normalize the data coming from these third-party tools into the Heimdall data format, or HDF, and provide mappers to go from HDF into a different standard for ease of use. Finally, the normalized data can be aggregated and visualized using Heimdall, the SAF open source visualization software, which shows all of the results from every security tool in one location instead of across a multitude of dashboards or CLI outputs. The full application allows you to upload previous results, making it easy to track compliance over time. If you happen to have a governance, risk management, and compliance or GRC tool, we also support ingesting the information into those tools. For example, eMasser provides an API into the DoD's eMass GRC, including the ability to upload your results there. And as mentioned earlier, the SAF CLI not only lets you convert from HDF into a select set of other standards, but in some instances enables you to directly upload into other services, such as AWS Security Hub and Splunk. So we've partnered with VMware to create the Vulkan application that I mentioned earlier. And the primary reason we created the Vulkan application is to streamline the process of generating security guidance that traditionally took 18 to 24 months. Right now, we want to show you a brief look at Vulkan. So here's a look at Vulkan and what the user interface originally brings you to. We have several projects that can be created, and these are based off of some sort of general guidance like an SRG. So in this case, we have loaded in a couple different guidance documents that are taken from DISA itself, and we can use these to create new projects that use this guidance and develop real technical implementation guidance for a specific application. So in this case, we've been developing a keycloak STIG based on this AAA Authentication, Authorization, and Accounting Services Security Requirements Guide. So this AAA SRG, this only gives us general guidance like your password should be secure using this many characters, that sort of thing. But it doesn't tell you how to do it for a specific application, like check this particular configuration file for that setting. And so what we do here is, in this case, Keycloak is an authentication account and access service. And so in this application, we can create a STIG ready content in this project. So if I open up this project, I'll be able to see all of the controls that were uploaded based on the AAA SRG. And this includes all of the information and data that was already there, like the status, which we will have to edit, as well as the title, a vulnerability discussion, and check and fix text, as well as the severity. So you can imagine that instead of making an entire Excel spreadsheet and going through this manually one by one, having all of this data pre-populated from the general guidance is going to help you when developing more specific implementation. So if I try to find a control here that needs to be developed, I can edit a control and actually determine what status is useful for this specific application. So can I configure this setting? Is it inherently met by the application? Does it not get met by the application? Or maybe in this case, it's not applicable for a particular reason of your particular implementation, because we are just basing it off of that general guidance. And then after that, you can continue to change and update the text for your specific application. In addition, this will help by exporting all of this data into an inspect profile. So here you can see an example of what one inspect control would look like based on this particular control requirement. And so this has all of the metadata that you would need, like the severity, the check and fix text, and all of those things, the NIST 853 alignment that we were seeing before. In addition, you could use Vulkan to write your describe block or the actual logic of your inspect profile in this particular control, and then have it added here and export this entire thing as an inspect profile. You can also export this as an XCCDF file or other formats that are useful for your own situation. So hopefully that gives you a little brief overview of the Vulkan application. And we'll go back now to look more at the idea of what this could lead to. So after you have this guidance, you want to create some sort of automation to harden, validate, and be able to look at the results of all of this information. So this is an example of an automated CI/CD pipeline, some workflow in GitHub, although you could run this in GitLab, Jenkins, or anything else really, where we specifically are using Test Kitchen to create an EC2, actually 2 EC2s, one vanilla and one hardened. And so we run the hardening content on one of them that we referenced earlier to harden and secure this EC2 according to the Red Hat 7 STIG, that Security Technical Implementation Guidance. Then in this workflow, after we created that vanilla and hardened box, we are able to run inspect profiles to validate both of them and then compare the results. We use the SAF CLI as a utility tool to view a summary of the results and validate them against a threshold so that in your automated process, you can get a green check or a red X that tells your pipeline whether it should pass or fail. For a bigger deep dive on the tooling of the SAF, you should take a look at the recording of MITRE's other presentation for ChefConf for this year.
So let's dig a little bit deeper into the MITRE SAF website at saf.mitre.org. And on this website, you can find information on the goals and inputs and tools for each of the 4 capabilities that we're going to go into detail now. So here you can see information on hardening, and we'll go to the next slide and show you the library of content that exists on the website. This is just a screenshot of the website. So these hardening scripts that Emily mentioned are based on the STIGs or CIS benchmarks, and they can be specifically tailored to your organization, whether it's for warning banners, password policies, etc. Similarly, the SAF contains a library of validation content based on the same standards. The inspect language that Emily talked about implements the compliance checks that can be tailored to your organization, which helps you eliminate false positives. SAF supports the validation of all controls, including both automatable and manual attestation of controls, which helps you to cover interview, examine, and policy use cases. This screenshot from our website shows the available SAF validation scripts, the ones we call inspect profiles. They can be used to validate the configuration of the entire component stack and run at any time. And note that it does cover the entire stack. So you've got content for the cloud service provider, the virtual platform, operating system, database, all the way up to the application tier. One key aspect of inspect is that it's flexible enough to run against any environment, whether you're on premises in your own hardware or in the cloud, and it works in a containerized environment as well. Here you can see the wide array of integrations we provide with various security products. We're able to take the results as standalone files or API integrations and normalize them into the Heimdall data format. On the right-hand side, you can see the tools that we already have Heimdall converters for, including Fortify, OWASP, SonarQube, DB Protect, Nessus, and even AWS Security Hub. SAF also provides a convenient dashboard for visualizing all the security tool results data that we showed on the previous slide. Heimdall will automatically recognize any file you put into it and convert it into an HDF format if it's supported. Aaron's going to show a demo of how to use the Heimdall visualization tool.
Thanks, Brett. Oh, Emily's going to do it for me. Wonderful. All right, so now we're going to take a look at how you can utilize Heimdall to visualize your security results. So as you can see, you can just drag and drop files directly into Heimdall here at the local file loading if you want to do things by hand. But today we're going to use some samples from our samples directory. And just as a reminder, anybody can go to heimdalllight.mitre.org to follow along or to play around with this after the fact. So if we take a look at Nginx with failing tests as an example. This is an example of an inspect run that we did to an Nginx container. And we evaluated the container according to the web security SRG, which we had aligned into an inspect profile, much like Emily showed earlier with Vulkan. And as you can see, this container is pretty well hardened. We've got 34 passing tests, and we only have 3 failures, and we've got 1 not applicable and a few not reviewed. So if we take a look at this, we can see that Heimdall helps us visualize and communicate this information at multiple levels. The first level just says what scan we have and when it was run. The next one is more what your CISO or your senior technology or security advisor might want to see. Just give me the details, right? Just the facts, ma'am. And then here we have donut charts that allow us to help filter and review this data. So if we want to take a look at the high open findings or the moderates or whatnot, or just get a better idea of the compliance level overall, we have got a compliance percentage here. So let's scroll down just a little bit more, and then we can take a look at that 853 alignment that we were talking about that aligns directly with many of our accreditation processes, such as the RMF, or other types of accreditation that you might do for your application to get approval to go to production. So we have it aligned right here to our primary index of security controls, and we can filter up and down those as you would expect. And then if we scroll down a little bit, we'll start to see the data table that allows us to see the details of each of the tests that were run in this profile and whether they passed or failed. So if we open up one of the failing tests as an example, we can get a better idea of where our specific problem is, helping us go down to root cause analysis. So as you can see here, we have one failing subtest from the inspect control that basically says, hey, this setting was expected to be less than or equal to 10, but it looks like somebody fat fingered it and added an extra 0, so it's 100. So we didn't meet that requirement. So now let's say that we handed this over to our security team that does the hardening for the Nginx boxes, and they say, hey, we fixed it. We're going to rerun the inspect profile again. And now they handed that back to us, and they said, hey, here's the new scan. Everything's fixed. So we say, thanks so much. And now we can see that all of our tests are failed, but let's make this even more clear so we can more easily communicate this. And Heimdall helps you do that by what we call the comparison view. So the comparison view allows us to take 2 scans or a set of scans and easily see the before and the after. So as you can see here, we've got multiple levels of information. We've got the amount of security controls in these donut charts. And then if we look down, we can kind of see, just like we could in the other view of Heimdall, the actual subtests and the requirements for each of the controls that we were looking at. And we can actually see, why did this go from failed to passed? So we can see that this test that we expected to be less than or equal to 10 is now 10, and it passes. And then we can scroll down a little bit, and we can see that the other 2 controls that were failing are now remediated. And we can see that this setting was set to what we wanted it to be. And the next one after that, same thing. So now we can have actual actionable evidence and a quick visualization to be able to show us very quickly and easily, that we met our requirements. So the other thing that we had talked about was, Heimdall server, which was just the database backend powered version of the Heimdall front end. You can imagine how we might be able to say, well, if we have a database behind Heimdall, we can start to look at things over time, but even more powerfully, we can load up all the supported data formats into Heimdall. So let's say in a realistic solution, we would probably have that Nginx box actually running in an environment, let's say AWS, with some S3 buckets on the back end. So if we load up the AWS foundations, the S3 benchmark, maybe that container is running on a Red Hat box. So we have the Red Hat baseline. That Red Hat box has the Nginx server on it, which has an application that we might have ran some OAuth scans against, or Burp Suite. And now we're starting to actually build out a real application. So if we load all those up, we start to see the application really come alive. So you'll see that we've got a lot more passes and fails, but this is a much more representative view of what an actual application that we might be trying to deploy into production might look like. And the tree map starts to reflect that in terms of the coverage of those security controls. And this is what people are talking about when they talk about defense in depth, right? Each of those 853 security controls aren't actually addressed by every part of your application stack. It's a unified view of all the components and how each of them support the security posture of the system. So if we scroll down a little bit, we'll also see that Heimdall allows you to, let's say, Emily, let's maybe go back up real quick and just filter, like, let's say the high open findings, which is kind of what people would want to look at. And so we can tell in this system, we've got 12 items that are cutting across our stack that we would need to remediate in order to probably get a go to go into testing, or maybe even into production. So we've got a few things that we need to fix in the AWS foundations. We have a couple things on our S3 buckets that we need to fix. We've got a few issues in the static analysis of the code base. We've got a couple things on our gold disk that we need to fix, et cetera, et cetera. And now I have an easy way to hand all this information to my security teams and my development teams to say, everybody is responsible for each part of the stack. Go fix your pieces, and then let's bring this back together. And as you could imagine, we can then take all these new scans, put them into the comparison view, and be able to show that same kind of before and after, to be able to have a data-driven decision about our risk analysis, that we can go ahead and make that decision to go into production. Now, some of the other things that Heimdall brings to the table is the ability to share this data across business systems. So we do that through the data normalization that we do, through converting everything to HDF. And then that allows us to easily convert the data and transform it into other formats that might be useful to the business process. Such as you can see here, we can export it into ASFF, so we can put it into Security Hub if you want to use that dashboard rather than Heimdall, or you can export it into a DISA checklist. If you need to upload some of these results into EMAS, we can export it as a simple Excel spreadsheet. We could export it into an HTML file if you wanted to attach these open issues or the current status of things to a Jira ticket or a GitHub or GitLab action, those types of things. Or we could just export it as a full-on JSON that you can load right back into Heimdall or share across teams, that type of thing. So we've tried to bring this all together so that you have one place to work, one place to look at data, and an easy way to communicate. All right, Emily, back to you.
So MITRE SAF and Progress Chef teams have been collaborating really since the beginning of the InSpec project. Our teams have been able to bring some exciting new capabilities to the InSpec community, including profile dependencies, inputs, attributes, enhanced outcomes, attestations and waivers, parallel execution, and so on. We've also been able to help the InSpec community with plugins and resource pack systems and countless resources supporting the InSpec community. During the Progress Chef team's presentations on what's coming in InSpec 6, and I didn't know you could do that with InSpec, and these MITRE SAF team presentations, we'll demonstrate how all of these InSpec capabilities can enhance your security automation workflow. And all of this happens in an open source capability. We're working with the Inspect core team to merge many of these capabilities directly into the core of the Inspect project. So the new attestation features, for example, will help users to fully attest to the security posture of their systems, not only in areas where testing can be automated, but also to articulate when tests are out of scope for the test event, which human validations have occurred, and relevant policy and procedural tests that have already been completed in the system's hosting environment or data center. So earlier you saw Aaron showing the Heimdall application. These may be things that were previously not applicable or not able to be reviewed, and now they can be reviewed much more easily and put together with that data to fully be visualized. So between the talks from each of our teams, we hope that you'll see some exciting new possibilities on the horizon to facilitate your compliance journey.
Excellent. So what we want to do now is open up the floor for questions and answers through the MITRE's team. So let's get started.